Welcome to Chemistry with Dr. Z. In this video, I'm going to talk to you about electrolysis, what does it mean, and then the electrolysis of molten compounds. So electrolysis means splitting up by electricity. In electrolysis, you're going to have a cathode, an anode, which is a positive electrode, and then a cathode, which is a negative electrode, and you're going to have an electrolyte, and the both electrodes will be immersed in the electrolyte. The electrolyte can either be a molten ionic compound or dissolved ionic compound dissolved in a solvent. And then we have an electric current which is passed through the electrolyte. The molten or the dissolved ionic compounds will have some ionic species, and these ionic species can move and they can conduct the electricity and allow the flow of the electric current. So what's going to happen? So we have positive and negative ions in the solution or in the molten solid. So first, the negative ions will travel towards the anode, and as they travel toward the anode, they are going to lose their electrons and will be oxidized. So if you have whatever the negative ion, we represent this by X minus. So at the anode, the positive electrode, they're going to lose the electron and they will be oxidized, while the positive ions will travel toward the cathode, which is the negative electrode, and there they are going to gain electrons and will be reduced. So as ions gain or lose electrons at the opposite electrodes, they form uncharged elements and they are discharged from the electrolyte as elements, not as ions. So when we talk about the electrode, there are the electrolyte. There are two types of electrolyte. The first one is the molten ionic compound. So electrolysis of molten ionic salts or solids or molten ionic compounds. First of all, we need to know that ionic solids as solids cannot be electrolyzed because the ions are fixed in their place and they cannot move. And the whole idea is having ions that can actually move and conduct the electricity or can allow the current to flow in the cell. So the molten ionic compound, however, when you melt them, the ions are then free to move. So they can be electrolyzed, and then we can use electrolysis to actually do the oxidation and reduction of the different ions. So an example of this is the electrolysis of molten sodium chloride. So molten sodium chloride, at the positive ions, which are the sodium ions, are reduced to the element sodium at the cathode. And the equation for this, the ionic equation, is that two sodium ions will gain two electrons and to give you the sodium element. So this is a reduction because it's a gain of electrons. While at the anode, the positive electrode, the negative ions will be oxidized there. So we have the chloride ions, which are the negative ions. At the anode, they are going to lose their electrons to give you the elemental chlorine as well. You can apply the same principle for any molten ionic compound, for example, lead bromide. So if you have lead bromide, then lead bromide as well, you're going to have lead as the which is the positive ions, which are going to be reduced to at the cathode, and the bromide are the negative ions, which are going to be oxidized at the anode. An example of the electrolysis of molten salts is the electrolysis of the metal ores. So we know that metals above the carbon in the reactivity series are more reactive than carbon, and they cannot be extracted by reaction with carbon. So these more reactive elements can be extracted from their ores using electrolysis. However, electrolysis is expensive and it requires lots of energy. So the typical example that we are going to discuss here is the extraction of aluminium from its ore, which is bauxite. So the aluminum oxide, which is Al2O3, this is the bauxite, and this is the ore where they use it for extraction of aluminium. So the electrolysis, you're gonna have the carbon anode, which is the positive electrode, and carbon lining as a cathode. And then you have the molten bauxite. The molten bauxite or aluminum oxide is usually mixed with cryolite, and the main reason for this is because aluminum oxide has very high melting point. So they first mix it with cryolite to lower its melting point so they can have a molten salt. Then in the electrolyte, we're going to have aluminum ions and we're going to have the oxygen ions. So aluminum ions are going to be aluminum 3 plus. This is the positive ion. They're going to travel toward the cathode, the carbon lining as the cathode. And they're going to lose their electrons. They're going to be reduced to aluminum, and the molten aluminum will collect at the bottom. So this is the aluminum collected at the bottom. And then we have the oxygen here as well. So oxygen ions will be oxidized and they're going to travel toward the carbon anode, and the oxygen will lose its electron to give you the oxygen gas. The overall reaction should be written, and you should know how to balance this equation as well, and how to put the state form for all the products and reactants. So we have aluminum oxide. It's going to be a liquid because this is molten, and this is going to give us aluminum and oxygen. When you try to balance this, you find that you need 2 of the aluminum oxide that will give you 4 aluminum metal and 3 oxygen. And the oxygen here is going to be a gas and it will be collected at the carbon anode.